Okay, so now what we're going to look at is the same data set that we looked at previously when we were looking at population proportions and how to estimate those from a sample, except now we're going to look at our quantitative variable being travel time. And so just as a refresher, what we're seeing here is we have 35 different high school students from North Carolina and their data in terms of how they reported traveling to school predominantly, whether it be car, bus, or walk in the case of this data set. And then associated with that is also the time it takes for them to travel to school using that method. And so in switching to this quantitative variable, we have a different question that we can consider now, and that's what's the typical travel time of a North Carolina high school student to get to school. Now again, we're going to make an assumption here that this sample is representative of North Carolina, which it may or may not be, okay? But for the sake of what our exercises, we're going to say it's representative. So the first thing we can do is let's look at the original distribution of travel times for this particular sample. And so one of the first things we always want to do when we look at a distribution is we want to talk about kind of the big elements of this distribution. So what's the shape of it? What's its center? What's the spread? And are there any outliers? So if we start with the discussion of the shape of it, this is almost a bimodal distribution. And so what I mean by that is we kind of have two peaks. One of them is over here on the left side on the low end, and then it dips off and trails off here in the middle, and then it kind of peaks and comes up and goes over again. And so the modes being the peaks, two of them bimodal. So when we start to describe then the center of this distribution, there's commonly two different ways that we do it. But the fact that this is bimodal means that the modes actually would be useful for this. So one of the modes being approximately 10, another mode being about 75-ish over here. If we use our typical statistical measures, though, we usually consider it in terms of the mean, so what's the average of the values, or the median being the middle value. And so if we look here, we actually have the mean being 43.7 minutes of travel time, and the median being 35 minutes of travel time. Now that's describing the center of the distribution. The last thing that we generally describe is the spread. And so the spread is talking about which values this variable takes up and how often it takes those up. And so if we look at this, we have values that range anywhere from about 0 to about 90 in terms of the values that it takes up. Most of the values are clustered either between 0 and 35 or between 60 and 90. The other measure of spread that we commonly use, though, is that of standard deviation. So standard deviation is telling us what's the average distance from the mean, essentially, of each of these values in the distribution. And so in this case we have a standard deviation of approximately 30. And the last measure of variation that we can look at to describe spread is from our box plot, and that's talking about the interquartile range. And so if we look at our lower quartile of 17 and our upper quartile of 71, what we're seeing is the difference or distance between those 2 points is a distance of 54, which would be our interquartile range. And that contains, between those two values, approximately 50% of all our observations, the middle 50%. Okay, so now that we've looked at the original distribution, we've described it, the next thing we want to do is we want to use this to make estimates for what is occurring in the larger population. So this is some small sample that we're assuming is representative of North Carolina high school students. We want to come up with an estimate of what is likely occurring, what's the likely typical travel time for all North Carolina high school students. And so to do that, we're going to follow a similar process to what we did with our categorical variable. And that's we're going to treat this sample as a population, and then we're going to randomly draw samples from it to create a sampling distribution. And so again, we're going to go to the collector here. And similar to what we did last time, we'll do small samples to consider. So we'll stick with that size of 10, and we'll take just 25 samples to consider for this. So when I run my sampler, again, it's randomly drawing 10 individuals to create a single sample. So if we speed it up a little bit, what we see here in our table is we have a single experiment, so a single run of this collector over here, that consists of 25 samples, and each of these 25 samples consists of 10 items to make our 250 items total. So just like what we did when we were dealing with our sample proportions, we still need to make a sample statistic, but this time we're going to look at sample means because that's the general measure of center that we're looking at for a quantitative variable. And so to do that, I have to add an attribute to our samples, and we'll just call this sample mean. And then we have to tell it what we're going to calculate with that. And so in this case, we want to calculate the mean, which in terms of what we do in this program, we just basically tell it collect a mean. But we need to tell it what we're collecting a mean of. And so our variable this time that we're considering is travel time. And so if we apply this, what we now see in our attribute over here is the mean of the travel times of the 10 randomly drawn individuals from our original sample. So let's graph this. So what you see here on the bottom is a new distribution of our sample means. Now, notice we have a quantitative distribution and we started with a quantitative one. So let's do some comparisons initially by talking about our distributions. So we described our original distribution, but now what we want to do is describe our new distribution. So looking at our new distribution here, again we want to look at the attributes of what's the shape, what's the center, what's the spread, are there any outliers. So in this case, when we start to talk about the shape, this looks much more symmetric than what we started with before. In terms of our measures of center, we can again look at the mean and the median, which are pretty close to the same, which again supports that symmetric distribution, because in a symmetric distribution, your mean and median should be close to one another. So we're right around about 42.5, 43. We'll use 43 just for the sake of simplicity in this case. We can also then talk about our spread. So our values are spread from 25.8 to 54.8. So about 25 to 55 is the spread of our values. And most of our values are clumped around the middle. If I look at my standard deviation is about 8.25. And then if I look at my box plot now, I can look at my interquartile range. So I'm going from 37.8 to 48.5. And so the distance between those being 10.8. We can also describe where that middle 50% is, again being between those two quartile values. Now another thing we can start to do is we can start to talk about the difference in the shape of the distribution, the spread of the distribution, and the center of the distribution of what we started with and what we have in our sampling distribution. So in our original distribution, our center was very similar to what we have now. So our center in terms of our mean was 43. Our center of our sampling distribution in terms of the mean is 42.79, so very close. Notice now, though, the shape has changed from what was originally a very bimodal distribution to what's much more of a symmetric distribution. Notice also the change in the spread. So our original distribution had a much larger spread, going from 0 all the way up to about 90, and with a standard deviation of about 30. When we look at our sampling distribution, now we're only spread from about 25 to 55, and our standard deviation is only about 82.5. So now, when we look at these distributions, these changes, what we're seeing is we're actually able to start to hone in on what we think is a typical value for this. And so again, I want to apply that same idea that we did with our categorical variable, in that we want to come up with a confidence interval. So what we're using for this is, again, that standard of about 95%. We want about 95% of the values to fall within some distance of the center. So our center in this case is 43. Now if we go 12 units above 43, we contain our max. If we go 12 units below 43, we contain all but these lower 3 points. But remember what we looked at last time. We have 25 points here, which to make it so that we have essentially 95% of those values contained in our interval, we want basically all but 1. So we're going to have to go a little larger with this interval because we really want to get down to containing at least 1 if not both of these. We could exclude them though. So again, if we excluded 2 points, what we would end up with is we would end up with approximately 92% of all our values instead of 96%, which is fine. Again, we're eyeballing this. So we still want to go a little larger though because we want to contain this 29 here. And so how far above and below would I have to go from the center, which is at about 43, to get down to below this 29.4? So we could round down to 29. So you're talking about a distance, in this case, of about 14. So if we go 14, in this case, minutes, below our center, in terms of our mean being about 43, then what we're going to find is that we're going to contain all but these bottom 2. So we're going to contain about 92% of the points. So let's use that now. So we have about a margin of error of 14. And if we're using that margin of error of 14, then we're going anywhere from 29 is the lower end of our interval, all the way up to 57 is the high end of our interval. So let's relate that back to the question that we started with. Our original question was, based on this sample, if we want to make a prediction now of what we think the general population of North Carolina high school students would report as their typical travel time to school, then we're fairly confident that that true typical travel time is somewhere between 29 and 57 minutes. And now we've seen a way that we can start to make estimates of a quantitative variable towards a population mean based on taking a sample and making inferences towards a population.